Hello everyone, my name is Ajay. So in this video I'm going to explain you about the problem called as rotate array. So here if you can see we are having an array of integers and we are having integer k. So we have to rotate this array k times from right side. So rotation means you have to move the last element of that array to the first index. So let's see, the first rotation the array would be, so in the first rotation you will move the last element to the first index, that is 5 here, so you will move 5 to the first index and all the elements will be then after. So this is the first rotation. Now let's see how it would be in second rotation. So now the last element is 4, now you move the 4 to the first index and all the elements will be then after. So this is second rotation. So this is the output. So the problem is to rotate the array k times. So that is the problem here. So let's see how we can solve this problem. So we can actually solve this by doing some reverse operations on this array. So let's see what actually we can do. So here if you see in the output array, we are starting from 4. The output array is starting from 4. So this 4 is actually at index 3 in the original array, index 3. So how to find that index? So we can actually find that index by simply subtracting the length of array minus k, which is 5 minus 2, that will give us 3. So first you will get that particular index, which is 3. So once you get that index, you will just divide that array into 2 sub-arrays just before that index 3. So we got the index as 3, and once you get the index, you will just divide this array into 2 sub-arrays just before this index 3. Okay. So now you have to reverse this sub-array. Next you have to reverse this sub-array, and then you have to reverse the complete array. So you will get the output. So let's see how we can do that one. So 1, 2, 3, 4. Okay. So now I will reverse this sub-array, which is 0 to 2. That would be 3, 2, 1. Okay. And now I will reverse this sub-array, which is 3 to 4. That would be 5 and 4. Okay. So then after I will reverse this complete array. That would be 4, 5, 1, 2, 3. So which is equal to output. So by performing these 3 reverse operations, I can get the output. So this is how we can solve this problem. So let's see how we can actually code this one. So for coding this, I would like to write the function prototype as rotate. I actually written the function prototype, which is rotate, which is taking input array and input k integer arrays, which is actually taking 2 input parameters. One is the integer of arrays and the second one is integer k. And now you have to perform the first reverse operation, which is 0 to k. So I'm just writing the reverse operation here. So I'll actually implement the reverse method. So before that I will just use that reverse method like so. Let me write the reverse function prototype. Reverse function prototype would be array of integers and int start, int end. So this is the reverse function prototype. I will implement this just after this. So I will call this reverse function 3 times in the main function. So first I will call the reverse function to reverse from 0 to 1. So I will pass array arr, and the start index would be 0 and the end index would be 2. How to get the end index, which is nothing but L minus K minus 1. So L is A of dot length minus K minus 1. Okay, so that will give me index 2. So this is one reverse operation. Next I have to perform reverse operation on this subarray, which is 3 to 4. So for doing that, I will again call reverse function. I will pass array here, and here the start index is 3, so which is nothing but L minus K. So I will length minus K, which is array dot length minus K, and the end index is last element of array, which is array dot length minus 1. Okay. So once these two reverse operations are done, I have to actually reverse the complete array again. So for doing that, so for reversing this complete array, this is the last element minus 1. So for doing that, I will again call the reverse function. I'll pass the array here, and the start index would be 0, and the last is length minus 1, which is AR dot length minus 1. Okay. So after performing these 3 reverse operations, I will get the output. So let me implement this reverse function. So for implementing this reverse function, first suppose if you are having an array of, let me write here. If you are having an array of 1, 2, 3, 4, and I have a start pointer here, and then pointer as at the last. Now you can actually reverse an array in a linear time by this approach. You have to just swap the start index and the end index. So which would be 4, 1. So you have to swap the start index and the end index, and you have to increment start and decrement end. So after incrementing start, it will come here. After decrementing end, it will come here. Again you have to swap the start and end, which will be 2 and 3. That would be 3 here, and 2 would be here after swapping. So by this way you will swap all the elements in the array, and finally you will get the reverse of the array. Whenever s is greater than n, then you will stop the operation. That means whenever s is greater than n, that means the array is actually in the reverse of the array reverse operation is done. At that time the s will be greater than n. So let's implement that reverse function. So for that I will use while loop. While start is less than end, I will swap the elements. AR of, let me take a for swapping we can actually take a temporary variable, and I will store AR of start in this, and now AR of start would be AR of and AR of end would be 10, and I will increment s and decrement end. Okay. So this is the reverse function. So I'm simply swapping the start index and the end index till s is less than n. So whenever s is greater than n, that means the reverse operation is done. That way we can reverse the array. based on the start index and end index. So I'm calling this reverse operation 3 times in the main function, and after this 3 reverse operation I will get the output. So this is the way that we can solve this problem. And also, there may be two scenarios. One is when k is 0. So when k is 0, you need to, there is no need for us to do any rotations. So I'm just making sure, I'm just doing nothing when k equal to 0. So if k equal to 0, I just want to return the function without doing anything. That is one scenario. And whenever k is greater than L, so let me show that one. So let me use this thing. So for suppose if I'm having an array as 1, 2 and 3 and k is equal to 5. So the length is actually 3 but k is 5. So where k is greater than L. So in this scenario, let me write all the operations. The first rotation, second rotation, third rotation, fourth and fifth. So after first rotation, I will get the array as 3, 1, 2. And the second rotation, I will get the array as 2, 3, 1. The third rotation, I'll get the array as 1, 2, 3. Again, the original array. Let me complete this. The fourth rotation, again I'll get 3, 1, 2. The fifth rotation, I will get 2, 3, 1. So here if you see, after 3 rotations, I'm again getting the original array. So this occurs when k is greater than length of the array. So here, if I actually rotate it for 2 times, then I'll get the output. So how to find that number 2 whenever k is greater than length of the array? So for that you can simply get the remainder of k. You can do mod of k with length of array and you can assign that to k, so that you will only rotate 2 times when k is greater than length of the array. So let me do that one. If k is greater than ar dot length, then I'm making k equal to k mod ar dot length. So this will solve my second scenario. So these are the 2 scenarios where you can optimize for this problem. One is when k is 0 and the other one when k greater than length of the array. Then you can optimize in the 2 scenarios. So this is this solution for this problem, and let's see the time complexity and the space complexity for this solution. So if you see the time complexity, so I'm calling the reverse function here. So this reverse function is actually it's a linear time, so it would be length of array. That would be so it would be length of array. So first reverse function, I'm passing the array which is from 0 to 2, that is 3 elements, and in the second reverse I'm passing the array which is 3 to 4, that is 2, and in the third reverse function I'm passing complete array which is 5 elements. So this is nothing but, this is again 5 elements and this is 5 elements. So I'm performing this is nothing but this is n and this is n. Okay, these 2 operations is equal to n times and this operation is equal to n, where n is the length of the array. So that would be 2n. So that would be 2n. So which is nothing but big O of n. Okay, so time would be big O of n, and let's see the space complexity. So here I'm not using any temporary array. I'm not using any temporary array or any temporary collection for perform the operation. So it is just the constant time. constant space which would be big of 1. So the time complexity is big of n and the space complexity is big of 1. So that's about the solution, friends. If you have any question, please post them in the comment section. Thank you for watching my video.